All right, so this is lesson 12. First question asks, which of the terms describes or is an example of a regulatory protein? It's the activator, the CAP or the cap, and the repressor. Which of the terms describes or is this an example of a small effector molecule? The inhibitor, cyclic AMP, inducer, and allolactase. Which of the terms describes an example of a sequence found within the DNA, LAC-A, LAC-Z, +1 and -10. Which of the above is not involved in the LAC operon, the inhibitor? Which of the following from above is an example of an structural gene, LAC-Z and LAC-A?
So for number 2, the LAC operon is regulated by 2 inducers, the cyclic AMP and a lactose. For B, the binding site for the sigma factor in RNA polymerase is the LAC-P, while the CAP, or the CAP site, is the binding site for the activator that regulates the LAC operon. The enzyme adenylene cyclase converts ATP into CAMP. Those sequences are found within the LAC-P promoter portion of the LAC operon. The LAC-L or LAC-I gene encodes the LAC repressor, while the LAC-Y gene encodes the lactose permease. Attenuation can regulate gene expression in bacteria, causing it to terminate prematurely. And then the meriozygote is the final one, which is where it has 2 copies of the LAC operon. And there's the work on that one.
Number 3. Number 3 is talking about the LAC operon again, and it's talking about whether or not it'll turn blue. And so part A is IPTG is absent, glucose is absent, and XGAL is present. Since glucose is absent, lactose will be used. The XGAL is present, but because your IPTG is absent, no beta-galactosidase is produced, which means that it's going to be no blue. Part B, your IPTG is present, which means beta-galactosidase is produced. Glucose is absent, which means you're using the lactose, and XGAL is present. That means you're going to get a blue coloration. Part C, IPTG is present, glucose is absent, but your XGAL is absent, so you're not going to have anything for the beta-galactosidase to cleave, which means no blue. Part D, IPTG is present, glucose is present, XGAL is present. Since glucose is present, you're not going to be using lactose, which means there's not going to be any blue. E, there's going to be 2 reasons why it's not going to be blue. Glucose is present and XGAL is absent, and therefore you can't cleave XGAL if it's not there.
For the fourth one, for the first one where everything is just normal, it's the wild type, it's inducible, then it's just kind of a normal transcription there. For the second one, we have the LAC repressor can bind to the operator but cannot bind to a lactose. Therefore, it would be non-inducible. It wouldn't actually be able to start it ever. For the third one, you look at both of those, and the F prime plasmid is normal, but the repressor can't actually bind to the operator site on the chromosome, so it would make it constitutive. It'd continuously be transcribing it there. For the fourth one, we see that it's a normal chromosome at the beginning, and the F prime plasmid has that repressor can't bind, so it would become non-inducible again. That repressor is always there, wouldn't be able to actually continue on through a transcription process there. And for the final one there, again, we see that the repressor can bind to the operator, but it also, the F prime plasmid has the OC as well, so that would make it constitutive as well, continuous again there. And there's that one.
Question 5, we've got the table. The first one, you're not going to have any transcription happen whether or not you have lactose, because you've got a defect in your LAC-L gene. Part B, you're going to have 1 copy made from each one because you've got a defective operator sequence. which means the repressor can't bind to the OC, which is found in part B. Part C, so with lactose, you're going to be able to make 2 copies. The first, on the chromosome, you're going to get a full transcription, and then the second one is going to be continuous. So obviously you're going to get one off of that, and it's not going to be able to stop. Without lactose, the F plasmid is not going to be able to transcribe, which means only the chromosome is going to have a copy.
And isn't that backwards? Because you have the OC. It's
Oh yeah, yeah.
Continuous. So the F prime plasmid will transcribe, but the chromosome won't.
Yeah,
because there's no lactose.
Where am I?
D.
Okay, so for D, you're gonna have your defective LAC-L gene on your F plasmid. So without lactose, I mean, you're not gonna transcribe anything for either one of those. But with lactose, your chromosome will transcribe. Part E, neither of them are going to transcribe without lactose, because obviously you don't have lactose. And then with lactose, you've got the repressor binds to the operator, which means there's not going to be any transcription. And there's the answers. There we go. Thanks for watching.
Thank you.